So we've found the volume of the large area here, and we are now going to look at the volume of the cap. So step 2 is going to be find the volume of, I'm just going to try to redraw this cap here over the AC axis. Find the volume of this right there. It's kind of hopefully floating in space. And sort of projected it down here for a reason. And so we find the volume of this cap, and we're going to find that, and I'm going to just call that like a V for the cap. And when we subtract that from 8/9, we are going to have the, what color should I do it in here? Let's do it in, I just want to do it in all the colors. We'll have the volume of our space up here, which will be our answer. Okay, so how are we going to find the volume of this cap? Well, I'm going to use integrals again, and we're going to use the same concept. We're going to take, so let's take a spot here and see what the volume of a column is above one of these spots. So this spot down here is going to be, I put some axes up here. This is C, and this is A, and this is B, and the base is going to be dA by dC. And what about the height of this? Well, let me just draw this again, sitting out here in space. This is supposed to be, this is over our little thing that we brought out here just to see. What is this height? Well, this height is just our function. This is 2 square root of A square root of C. So that's our, from this very lowest point here on the AC plane all the way up to the top of our cap would be 2 root A over root C, 2 root A root C, and this height right here is going to be just 1. So that means the from here to here, what's this length? This is let me just put a circle. That distance right there is going to be 2. This is 2 root A root C minus 1. Okay, so now we can find the volume of this in terms of dA, dC, and the height. It's going to be 2 root A root C minus 1 times dA, dC. And we are going to sum up those. So let me just do the integral sign, which is an S for a reason. We're going to sum these up over this space right here. So now I'm back on this graph right here. We're going to sum them up over this region right here. So I'm just going to draw that region. And I'll even make that little green thing in the middle, because that's so cool. Okay, so how are we going to find this area right here? That's where our analytic algebra comes in. So let's take this CA axis. So I'm going to put my C here and my A here, and let me do it in cyan. So we're C and A. Okay, so that C right there is right there. That A right there is right there. So I just took this plane and I stood it up and put it over here for you. And if that's not helpful enough, let me draw the unit square in the same color. And let me draw this yellow area right here. I'm going to draw a little bit better because I already know what it looks like. And you will too in a second. I mean, you already know what it looks like. I'll I'll argue that. And so what is this point? Well, first let's just remember what this cap was sitting on, right? This cap was sitting right up here. It's sitting right up here. And when you took it off, what was it sitting on? It was sitting on this thing right here. When we came up with the equation for this curve, we found that this curve right here is C is equal to 1 over 4a. And if you don't believe that, we can redo it. That's what we came up when we said b is equal to 1, and we found that well, let's write that again, because it's not trivial. It's kind of cool, right? At b equals 1, so we're on the top on this plane up here. I think I was doing it in green maybe. At b equals 1, 1 is equal to what's the curve? 2 root a root c, and solving this for c would get root c is equal to 1 over 2 root a, and that's the same as c is equal to 1 over 4a, which is what we have right there. Okay, so that's the in a nutshell, that's what we were going for. Let me get rid of some of this because we're going for because this is going to help us set up our limits of integration. So what are we on? Yellow. Okay, so again, these points at a equals 1/4, right? So 4 times 1/4 is 1. 1 divided by 1 is 1, and we're right here. And here's a is equal to 1. So you can see as we set up our limits. Remember, we're going for this guy. We're looking at this one right here. So how to set up our limits. A is going to vary from 1/4 to 1. So A is going, I like cyan better. A goes from 1/4 to 1. And how does C range? Well, C really depends on A. So if we put an A over here, right here, so let's just call that A underline. It goes from here to here. It goes from this point right here in terms of A. C in terms of A is going to be 1 over 4, whatever that number is right there. So it really depends on A, and then it goes all the way up to 1. Right? So C goes from 1 over 4a to 1. It's probably the second hardest part of doing this problem. It's just setting this up. So we're ready to talk about this area right here. Ready to talk about that? Well, we're going to set up our limits of integration this way. This is we're looking for the double integral. This is just for the cap, right? Let's make that. We can describe this area now. A goes from 1/4 to 1. C goes from 1 over 4a to 1. And we have our function we're integrating here. 2 root a root c minus 1 dA dc. This is the last integral we'll take. That's going to give us the volume of the cap, which we will take away from 8/9 to give us our answer. And this integral I'll take in the next couple videos, but just setting it up was the doozy. You can use Wolfram Alpha, you can use Mathematica, there's probably graphing calculators that will find this integral for you, and